Electricity is the lifeblood of our modern world. It powers our smartphones, our computers, and our cars. But there is one major problem with electricity. It is completely invisible. You can look at the wire and see the electrons moving inside. So, how do engineers and technicians know what's actually happening inside a circuit? Enter the oscilloscope, often called an oscope by professionals. This remarkable piece of equipment is essentially a magic window into the world of electronics. It takes invisible electrical signals and translates them into a visual graph that we can actually see, measure, and analyze. To understand how it works, imagine a simple graph. On an oscilloscope display, the vertical axis or the y-axis is represents voltage, and the horizontal axis or the x-axis is represent time. As an electrical signal comes into the machine through a probe, the oscilloscope plots the voltage level at every tiny fraction of a second. To understand how it works, imagine a simple graph. On an oscilloscope display, the vertical axis or the y-axis represents voltage, and the horizontal axis or the x-axis represents time. As an electrical signal comes into the machine through a probe, the oscilloscope plots the voltage level at every tiny fraction of a second. The result is a continuous line called a waveform. By looking at this waveform, you can instantly tell how a signal is behaving. Is it a smooth rolling AC sine wave, or is it a digital square wave turning on and off, or is it a chaotic, noisy signal indicating a failing component? The shape tells the whole story. If you look at the front of any oscilloscope, you'll see a lot of buttons and knobs, which can be intimidating. But they generally boil down to three main control systems. First, vertical system. This controls the volts per division. Turning this knob stretches or shrinks the waveform vertically, allowing you to zoom in on tiny millivolt signals or zoom out for large voltage spikes. Second, the horizontal system. This controls the second per division. It stretches or shrinks the waveform horizontally. It lets you see a signal that happens in a slow heartbeat, or zoom in to catch a glitch that lasts for a millionth of a second. And third, the trigger system. This is perhaps the most important feature because electrical signals repeat thousands of times a second. They would normally look like a blurry mess on the screen. The trigger tells the oscilloscope to wait for a specific voltage level before it starts drawing the graph. This freezes the repeating waveform on the screen, make it stable and easy to read. So, who uses these machines? Almost anyone working with complex technology. Electronic engineers use them to design and debug computer motherboards. Automotive technicians use them to read signals from a car's fuel injectors or spark plugs. They are even the foundational technology behind the medical monitors that track our heartbeats. Multimeter can tell you the average voltage of a battery, but only an oscilloscope can show you the dynamic, living, breathing reality of an electrical circuit. It turns the invisible into visible, taking the guesswork out of electronics. And that's all for the explaining about oscilloscope. Thanks for watching and see you in the next video.